The second reason why acid chlorides are or acid chlorides is a better reactant for a nucleophilic acyl substitution reaction than an amide is for the following reason. And let's see this, let's understand that these leaving groups also have lone pairs, and one can assume that they can undergo this type of, they can exhibit resonance and undergo this type of resonance to give you now this cannot be ruled out. Now this cannot be ruled out, and in amide also you can think of such a resonance structure. Sorry, this has to be a positive charge. Okay, right. Now, the weaker the basicity. So what we have said is that Cl minus or Cl is a weaker base. So Cl is a weaker base, and we also said that NH2 minus is a stronger base, and hence it is a poor leaving group. That's what we saw in the first part of this video. Now it also is to be noted that weaker bases are better at withdrawing electrons inductively from the carbonyl group. That is, weaker bases are better at, so weaker bases are better at withdrawing electrons inductively from the carbonyl group. So we know that so this is a weaker base, and hence it does not contribute that well to form the resonance. So it is withdrawing electrons towards itself, whereas in case of amides, the ability to withdraw electrons is much weaker. Here it is very weak, and hence because it is withdrawing electrons from the carbonyl, this can leave easily. This is a good leaving group. And second thing is, because it is not withdrawing electrons in this direction, the possibility that there is a, so we can represent this like there is a C double bond Cl is much less. Now that's what you get from your resonance contribution. So this is much less, whereas here this resonance the contribution of this resonance structure is comparatively very high. So this is more like a double bond. So this contribution is quite high. It contributes highly. This resonance contributor contributes highly to the resonance hybrid, whereas this does not contribute much. Okay, so this does not contribute much, and hence weaker bases are better at withdrawing electrons inductively from the carbonyl group, and hence they are also better leaving groups. So we can combine and say that weaker bases are better at withdrawing electrons inductively from the carbonyl carbon. The less the less the carboxylic acid derivative is stabilized. Okay, so I sorry, so this statement is wrong, so just a minute. Thus, we can say that weaker bases are better at withdrawing electrons inductively from the carbon, and hence the less it is stabilized by electron delocalization, and therefore they will be very reactive. So we can say that because Cl is a weak base, it is better at withdrawing electrons. So since Cl minus is a weaker base, it withdraws electron better, and hence it is less stabilized by, so this is comparatively much lesser here, and hence more reactive it will be. Whereas if you take in case of amides, this is not a very good at withdrawing electrons, and hence it will, the resonance structure that is formed by electron delocalization is also quite high. So here it is also quite high, and hence it will be less reactive.